Hi, and in this video I wanted to talk to you a little bit about moisture meters. Moisture meters are widely known within the building surveying profession, and those of you who've undertaken local authority inspections of framing will be familiar with moisture meters. You'll have used them in your daily work and recorded their readings. Nonetheless, I thought it would be very helpful to talk a little bit about moisture meters in greater depth, and in particular the different types of moisture meter, their application, and more importantly, their limitations. So moisture meters come in varying types, and each of them work in slightly different ways. There are a number of well-known manufacturers such as Fleer, Trotec, Protometer are the three of the ones that are predominantly used and that you may come across, but they all fundamentally work in similar ways. So the first one I want to talk to you about is this creature. So this is a Protometer Survey Master. Moisture meters range in price from around about $20 up to about $1,000 for something like this. And if you want to go even further with some of the other more complex sorts, then you're up into $2,000 plus. Nonetheless, they'll work in a very similar way with varying degrees of accuracy. So the important thing to understand with a moisture meter is that, like all technology, it's rubbish in and rubbish out. So if you don't follow the protocols at the beginning of the process, then at the end of the process, the readings that you get and the information that you provide may be questionable and, more importantly, questioned. So this moisture meter operates in two ways. It operates in what's called resistance mode, and it will operate in what's called capacitance mode. And I'll talk a little bit about that later. So the first type of function that it has is resistance mode. And the resistance mode is accessed by using the pins at the top of the meter. Now, the first thing to understand about the moisture meter when it's operating in resistance mode is it is not measuring moisture. I don't want to hear anybody call it a damp meter, by the way. It doesn't measure damp at all. So the way it functions is by recording the resistance of an electrical current between these two pins at the top of the meter. Always use it that way, then you'll always know that your readings are consistent. If you use it like this, your readings will still be consistent, but they will read slightly differently. The resistance rather, is slightly less going that way than it is that way. That's to do with the way that the grain flows. It's nominal, but that's the process anyway. Now this piece of timber here, I have pre-wet, so it might give me a slightly higher reading. Not particularly, but this side of the timber has given me a reading of around about 11.8, while this side of the timber is giving me a reading of about 16 or thereabouts, and that's just because I wet the timber to show you the difference. What's important to also know with these meters is that the depth at which you push the pins into the timber will affect the reading. So if you've got a piece of timber that's very wet and you push the pins in as far as you can, which is quite a long way because they're pretty sharp, you will get a much higher reading than if you just literally push them into the framing a couple of millimeters. I don't know if I can demonstrate that here, but if I push the pins in here, I'm getting 12.7. If I push them even further, I'm up to 15.6 now. And that's really important to understand because it shows that there are wild variations with readings. It's nothing wrong with the meter. The meter is doing exactly what it's intended to do. It's about the operator. And so if you're going to take readings with a meter, multiple readings with a meter, then you need to make sure that your methodology for getting the reading is the same in all of them, because if it isn't, then you're going to find that your readings are inaccurate. Similarly, if you are working in tandem with another surveyor, which is often the case if you're doing evidential work, because all the parties who are subject to the claim are allowed to have experts present, and they may all take readings on the same piece of framing, they all may all get different readings. That might be because they either use different meters and they all read slightly differently, or they're pushing the pins into the timber at varying depths. So the only thing that you can ever be sure of is the reading that you took on a given day with your meter. And I made this point at a recent arbitration where I brought in different pieces of timber with different readings on, with different amounts of moisture in, to show the arbitrator the wild difference in the readings and the fact that if you push the pins in further, you get higher readings than if you don't. And this is because moisture readings are typically taken as an absolute when given in evidence, and that can create problems because people focus on the number. So if you give a reading of 19.5%, people go, well, it's over 18%, so the framing must be soaked, must be wet, so there's a defect. Now, I can guarantee on a piece of framing where if I push the pins in just about a millimetre, I can get maybe 17.5%, which is under the acceptable limit. If I push them any harder, I can probably get it over 18, possibly over 19 even. So the takeaway from that is that it's an indicative moisture reading. It's down to the skill of, well, not skill, but it's down to the methodology of the operator. And the readings that any one operator will get may be different from another operator using a same meter or even a different meter on the same piece of wood. So that's a little bit about moisture readings using resistance mode. Now, because it operates in resistance, again, things to be wary of is that if you get this anywhere near metal, it will give you a very, very high reading. So if you accidentally push it through a carpet and touch smooth edge, you'll get a very high reading. And I have seen building surveyors do this. They've pushed it through carpet at an edge, trying to work out whether the carpet's damp due to condensation or water coming underneath an external wall onto a slab, and they've got high readings and had their eureka moment, only to realise they've just touched one of the pins on a nail and another on one of the spikes in the smooth edge and got a really high reading. So really important to understand that. Same as if you pushed into a piece of timber and there's a nail, you'll get a false positive. And butanol will also give you a strangely false positive. And what happens with butanol, and don't ask me to explain why because I don't know, if you hold the pins on butanol, the reading is nominally high, but then it climbs. If you watch the meter, it will just keep going up and up and up and up, which is really strange. I don't understand why, but anyway, that can be a discussion for another day. So this meter also operates in another way, and that's what's called capacitance mode. And in that mode, it uses a sensor which is on the back of the meter here. This sensor reads to a depth of about 10 to 12 millimeters. So if you fire the meter up and press this little arrow on the side, it changes the reading onto the pad at the back, or the sensor. And again, this is really useful if you're scanning a wall. You can cover a large area and try to isolate where there may be a patch of moisture behind the plasterboard that you need to investigate further. It measures on a scale of 0 to 999. You can see if I put my hand on the back, you get a 999 reading, because thankfully I'm full of liquid. If I wasn't, I'd probably be needing urgent medical attention. So this is a really important and useful tool, and allows you to scan large areas of wall without causing damage to the wall as well, because some owners take a dim view of you sticking pens into their paintwork. And this will allow you to do that without leaving any trace of the fact that you've been there, which is really useful. And I've used this on many occasions for helping to isolate a part of a wall where we need to investigate further, either from inside or outside. Again, highly susceptible to metallic interference. So if you pass this over a piece of electrical cables, or any sort of trim underneath plaster or anything of that sort, or nails, it'll give you a false positive. So again, down to the skill of the operator, you need to be aware of its limitations. It doesn't provide you percentage. Again, it's just an indicative reading between 0 and 999. And if you pass this over a piece of dry plasterboard, you'll get a reading around about 80 or 90, maybe 100. As soon as you get anything that's slightly moist, it will start climbing quite quickly. It's very sensitive. So that is the moisture meter operating in resistance and capacitance mode. Now there are other meters available that operate just in capacitance mode. Trotec do one. It's got almost looks like a metal lollipop on the top of it with a little bubble, and that reads in capacitance mode. Protometer do one, which is a larger moisture meter. This pad at the top is exactly the same as the one that's on the back of the handheld meter. Operates in capacitance mode. This allows you, with this one, it has an extendable wand, which allows you to do ceilings or floors if you don't want to kneel down. Very, very useful, very expensive. Because it's a dedicated capacitance meter, it will read at a greater depth. I think this one goes to about 25 millimeters. So it'll give you much greater depth than the handheld one will, but nonetheless operates in the same way. Equally susceptible to interference from electrical cables and other metallic objects within the wall itself, such as bracing straps and those sorts of things. So really important to be aware of those. Okay, so that's resistance and capacitance moisture meters covered reasonably quickly. There's another type of moisture meter which I want to talk about, and that is this fella here. So this is also a protometer. It's a much older model than the ones that I've showed you already. This is about 20 years old. It's called a protometer MMS, and it's a really, really clever piece of kit. Again, quite old, but works perfectly well. And this will do all of the things those other meters I've showed you will do. It has a capacitance pad on the back. I can put some remote probes into the side here, like that. Which allow me to then take readings using the pens in framing, and because it's on a remote cable, I can put this in my hand inside a wall and reach out a piece of framing. Problem if you don't use these probes, the remote probes, obviously if you shove the meter itself into a wall space, you can't see the screen then, which is really problematic if you want to photograph it. So it's quite handy having these remote probes, and the other meter I showed you will also have these remote probes. It means that you can put your probes into the piece of timber and photograph the screen of the meter to get your reading. But what this meter also does is it's a hygrometer. So what you can do with this, using the detachable sensor on the top, this will measure the humidity of the room that we're in, and it will also measure the temperature of the room that we're in. And then by plugging this probe into the side, this is like a little bimetallic strip on the side here. By using this meter, I can calculate, the meter calculates the dew point within the room. So what that is that's the point at which water vapor converts back to liquid within a room. So we all know that condensation typically forms on cold surfaces. So in a room where the temperature drops below the dew point, you can then expect water vapor to convert back to liquid moisture on the surfaces that are below the temperature of the dew point. And this meter here will tell you firstly what the dew point is in the room, which it does just like that. So it measures the temperature and it measures the humidity within the room. It'll calculate the dew point. But then with this temperature probe on the side, if I place this on a wall, it will tell me whether that wall is above or below the dew point, and it will tell me whether condensation can form on it. So that's a really useful tool if you've got a situation where you're trying to resolve an internal moisture problem, or you have a client who believes that they have an external moisture problem, and you're trying to prove that it's actually an internal moisture problem. This is a really useful tool, and it will calculate the humidity within a room and the temperature, and calculate the dew point, and then using this you can actually measure the temperature of the wall. So it says on the side of it, surface thermometer, and that's what it does. It measures the temperature of the wall that you put it on, or the surface. So again, a really clever little tool which will help you resolve some of those niggling problems that you may get from time to time. There is another type of moisture meter which I want to talk about briefly. It's a meter that you probably won't come across very often, and it's probably a scenario that you won't come across very often. But nonetheless, it's quite a useful thing to know exists, and I have used it quite a few times in the past, particularly when I worked for a territorial authority many years ago in the UK. So this is called a calcium carbide speedy moisture meter, and it's a rather intriguing looking moisture meter, and it looks like something that a drug dealer might have, but it isn't. So how it operates is by looking at the moisture content of a physical sample of material and calculating the moisture content of it, and it does that the following way. What you have to do is that you have to take a sample of the material that you want to measure, and usually the way to do that is to drill into it. So concrete, screed, any cementitious material, plaster, for example. We use these a lot for measuring, recording what's called rising damp in the United Kingdom, which is a very well-known phenomenon that occurs in brick masonry and stonework. And we take a sample of the material by drilling into it, and we get the powdered residue from the drill, and we capture it and place it into this little scoop here. And this little scoop sits on a balance which is preloaded, so that you can, as soon as you put enough in there and the balance reaches the midpoint, you know you've got sufficient quantity to test. So once you've done that, you take this pressure vessel and you unscrew the top of it, and you place your sample of the material from here inside. Next, you take the reagent, which is a calcium carbide powder, which is in this tin. And I'm not going to open the tin because it smells like rotten eggs and it is really unpleasant. So I'm not going to take the lid off. But when you're testing, obviously, you must do so. Then what you do is you take this scoop, which comes with a kit, and it's got a little pry bar on the end of it, which is really helpful to get the lid off. And you take 2 scoops of this material, of this powder inside, and put it inside the lid of the pressure vessel. And having done that, you place the 2 together like that and screw the lid together, creating a seal. So this is now a sealed pressure vessel. And then you shake it a little bit like Tom Cruise did in Cocktail. And you shake it for about a minute, you tap it, then you shake it again for a minute, and I think then you let it stand again. And then you take a reading off the bottom of the pressure vessel. I haven't used this for a long time, so the methodology may be a little sketchy, but it comes with clear instructions on the lid. And you take a reading off this dial at the bottom, and anything over about 8 or 9 shows that you've got excessive moisture within the sample. There is a little guide there which shows you how to interpret the readings off the bottom of the dial. This is a really good meter for a number of reasons. So the first thing is it's really, really hard to get an accurate moisture reading within a cementitious material. And that's because the cementitious materials themselves typically can give you quite high readings and quite sort of high positives. And that's to do with salts and so forth that sometimes occur in them. Particularly in situations where you've got efflorescence, because those salts will reduce the resistance dramatically and give you very high readings on the electronic meters. There are electronic meters that are designed to look at concrete, and some of those are pretty expensive. This operates slightly differently. What it does is the calcium carbide is extremely reactive to water, And so if you put a scoop of that into a glass of water, it will almost jump out at you on the table. It's really, really explosive. And so by putting that inside this pressure vessel and mixing it with the material that you've taken from the wall, it creates a gas inside here, which is held because it's a sealed vessel, and it pushes a diaphragm in the bottom of the pressure vessel and gives you a reading on the bottom. This unit complies with the UK Health and Safety Executive, so it'll stand up in a court if you use a reading from this device. It has to be calibrated like all other meters, otherwise you might get challenged, but it is a really accurate meter. And the thing that I really like about it is it doesn't use batteries, because as we all know, batteries will always run out just at the time that you need them. So a little word to the wise, if you're using electronic moisture meters and you have them in your kit, always have spare batteries with you, because I guarantee that the battery will go flat right at the time that you need it the most. So that is a little whistle-stop visit around moisture meters. They are incredibly useful. They are probably considered one of the most basic components of a building surveyor's kit, and they can be really, really helpful to provide you with useful results in your investigations. But as I said at the outset, the most important thing to remember is use the right meter for the right job, understand how it works, understand the limitations of the meter, and use it within those. I hope this has been helpful for you, and I'm sure that we will discuss moisture meters further as the course progresses. Thank you very much for your time.